Hi, I'm Miss Ouderkirk, and I'm going to help you learn how to complete the square. The purpose of completing the square is honestly just to get something in vertex form like you have here. So you should have already learned that when you have an equation where there's an x minus h and it's squared plus k, this h and k are the vertex of a parabola. And I'm hoping that you know that already. So I'm going to jump in and I'm going to tell you a little jingle. I'm going to move my little screen here. Um, and this jingle isn't like a song or anything. It just helps you know the process. So completing the square, I want you to think this as you're doing it. So you half it, you square it, you balance out the sides. Okay, so you half it, you square it, you balance out the sides. You half it, you square it, you balance out the sides. Okay, so have that in the back of your head as we do these problems, and hopefully it will make sense to you as why this jingle helps. So you half it, you square it, you balance out the sides. So here, we're going to start with this problem right here. And what I'm going to have you do is go ahead and write that down if you haven't already. And when we do a problem like this, I am going to have you write the actual problem, x squared plus 13x plus, and notice there's a c. We are going to figure out what that number needs to be. Okay, that number needs to be the constant, or the c, like not a variable, where it would complete the square. So what you're going to do is you are going to take the b term. So it's in standard form. The b term is right here with x. So there's my b term, 13. I am going to half it, as in cut it in half. Okay, when I half it, I'm going to get some number. So think about what number that would be. And in this case, I'm going to leave it as 13 halves. You can change it to a decimal, and that's totally fine, but I'm going to leave it. So I have 13 halves, and I'm going to put a little parenthesis around it. So I half it, and then I'm going to square it. And actually, I'm going to change this. It's going to be like an arrow. And I'm going to square that. When you square a fraction, you literally square the number on the top, and then you square the number on the bottom. So I'm hoping the number on the bottom isn't too bad. 2 squared should be 4. 13 squared, take a second to figure that out, but it should be 169. Okay, now let's take this jingle again. You half it, meaning you half the b term, which we did, it's 13 over 2. Then we square it, which is 169 over 4. And then we balance out the sides. Now in this case, there's no sides. There's no equal sign. And so there's not like a left side and a right side. So we're just going to use that 169 over 4, and we're going to put it right here. 169 over 4, which is a really ugly number. And again, you can change it to a decimal if you want. But that is the C term that we would put in there to complete the square. Now, if I wanted to see, like, this is the answer, 169 over 4. But if I wanted to see, like, what am I talking about? What is the square? What this means is that it is in the format of x plus 13 squared. And sorry about my writing. I'm using a new tool to help me write on the screen, so it's not the best. And x plus 13 squared. That's a plus. Okay, notice those are two binomials exactly the same. So that's saying x plus 13 over 2 squared. So I just completed the square, 13 over 2 squared. Now this, even though it's not an equation, is in vertex form. I have the x plus or minus a number squared, and then this k term isn't there. There's no k at the end, so it would just be 0. But I just changed the original problem, x squared plus 13x plus c. I figured out what that c needed to be by completing the square. All right, let's try this one. This one actually is an equation, so there are two sides, a left and a right. So we're still going to do the same thing. We're going to half it, we're going to square it, and now we're actually going to balance out the sides. So I'm going to rewrite it, x squared plus 5x. Now watch, I still leave that gap as if we're going to do a c. Like we need to find out what that c is, that constant term. And then I'm going to say minus 9 equals 0. So I need to figure out what this term is, which I don't have right there. There's my ugly arrow, but there it is. Okay, so think of the jingle. I half it, I square it, I balance out the sides. Okay, so you're going to take the B term, which I'll label this B term right there. So I'm going to half it. What's half of 5? And again, you can leave it as 5 halves, or you can change it to a decimal. So I halved it. I cut it in half. Now I'm going to square it, and I'm going to put it right up here. So again, you can do this on the side if you want, but you have to think of what's 5 squared, put that on the numerator, and what's 2 squared, put that on the denominator. So 5 squared is 25, and 2 squared is 4. So I half it, which I did. I square it, which I did. And now this is where balancing out the sides comes into play. I just added 25/4 to the left side of the equation. But hopefully you remember, you can't just do something to one side. You have to do it to both sides of the equation, and this is where balancing out the sides comes into play. So I'm going to say plus 25, whoops, my picture's in the way, 25/4 on this side. Okay, take a second, make sure you've got that all written down. And I'm going to rewrite this. I'm going to rewrite this whole thing as x. Now, hopefully you know that, and I haven't really gone over this yet, but hopefully you know that the term right here that's in parentheses, that 5/2, that is the term that we actually will have as our h. So I have x minus, plus 5 halves squared. And then remember, I have this minus 9 on the outside, and I have this 25/4 on the outside over here. But I need to solve. I need to get that x plus 5 halves squared by itself. So I'm going to move that 9. Okay, so hopefully you'll know that you're going to add 9 to both sides. Let's try that. Okay, and I'll give you a second right there. You're probably going to want to grab a calculator, or you're going to want to convert that 9 into a fraction so they have the common denominator. You know what? I'll go ahead and do that right here on the side. So I'm going to put this over 1, and I need the common denominator of 4. So that 9 over 1, or 9, has the denominator of 4. So I'm going to say times 4 times 4. So I have 36/4 that I need to add to 25/4. So these two are going to be added together. I know it's kind of a mess, but those two I need to add together. And I'm going to pull up another slide, and I'm going to see how this will work. Okay, I literally just screenshotted the last slide and put it on here. And so now I'm going to take what I've got, and I've got this x, put in parentheses, x plus 5 halves squared equals, and I've got that 25/4 plus the 36/4. And yeah, these numbers are not pretty, but you do have access to a calculator, so definitely use it. So then I end up with having x plus 5 halves squared equals, and when you add those together, the 25 and the 36, you should get 61/4. And again, you can use a decimal. It just comes out a little bit easier with the fractions, even though they're kind of scary for most kids. Okay, just like we've done before. So you should have done this before when you have like a big chunk that's squared on one side of the equals and then some number. You need to take the square root of both sides. So when you take the square root of both sides, you remember you get a plus and a minus version. So I'm going to take the square root of the left side and a square root of the right side. Now, for those of you that do not know or didn't remember, when you have a square and a square root, and they completely cancel each other out. So a square undoes a square root undoes a square. Okay, so what you would have left, and again, I'm running out of space again, so I'm going to go up here to the very top. So all I have left is x plus 5 halves on the left equals plus or minus, what's the square root of 61? I have no idea. So I'm just going to write square root of 61. Okay, and then I go, if I look down here, square root of 4, because I can do those separately. I can do the numerator and denominator separately. So the square root of 4, I'm hoping you know that, but the square root of 4 is just 2. So I'm going to say 2. So I just took the square root of both sides. The left side comes out nice and pretty, just x plus 5 halves. But the right side comes out kind of ugly, and that's okay. Okay, and then I'm going to get that x by itself. So I'm going to say minus 5 halves. Minus 5 halves. And again, trust the math. Don't freak out because it's ugly. There's going to be a lot of ugly problems in here. So x equals, I have a negative 5 halves, which is just a number. It's just a constant. Negative 5 halves. But then I have plus or minus square root of 61 over 2. That actually is my answer. And if you didn't know it already, that is actually 2 solutions. You have a negative 5 halves plus square root of 61 over 2, and then you have a negative 5 halves minus square root of 61 over 2. So that is the answer, and that is how we complete the square. We half it, we square it, and then we balance out the sides. And in this case, I actually solved it for you. So sometimes you'll just have to complete the square. Sometimes you'll have to complete the square and set up the equation so it's balanced. And sometimes you'll actually have to solve it all the way. And in this case, I did all those. Okay, here's one more problem. Again, I'm going to go over the jingle. You half it, you square it, you balance out the sides. And in this case, we have a function, f of x equals, and then it has this whole thing. Notice the a term is no longer that invisible 1. So this changes everything. We still are going to do all the steps, but let's get rid of that 4 first. And we can't just like up and move it and let it disappear. We're just going to factor it out. So we're going to start this problem just like we did all the rest, and we're going to rewrite it. So I'm going to say f of x equals, now this is where I'm going to change a little bit. 4 on the outside. I'm dividing out the 4 or factoring out the 4. 4 and then x squared plus, if I divided this b term by 4, what would you get? I'm hoping you know it's a 6. So I'm going to get 6x, and I'm going to leave the gap just like we have been, close the parentheses, and then I have this random minus 7. Okay, because that minus 7 isn't helping for completing this square. I'm just bringing it way over there. Okay, so I rewrote it with my little gap where I'm going to fill in that c term, the thing that helps complete the square. All right, so I've got this, and I've got the 4. We're going to keep this the exact same way we have been doing. So we're going to half it. Find the b term, cut it in half. So here's the b term. So I have 6 divided by 2 equals 3. Okay, so I halved it. This is the term I'm going to get. The nice thing about this problem is that it comes out to a nice pretty answer. Okay, so I've got 3. So I half it, and then I square it. So I'm going to take this 3 squared and put it right up here. 3 squared is 9. Here's the tricky part. There are no 2 sides of this equation per se because I have the f of x. It's not in a number over there. It just says f of x equals. So I'm going to keep everything on one side of the equation. I'm going to keep it on this right side, like with everything else, not with the f of x. Okay, so I just added 9 to this equation, just randomly added 9. But that's actually not a 9. It's a 4 times 9. Because remember, we already factored out that 9, or the 4, so we have to keep that in mind. So think of 4 on the outside and then a 9. What's 4 times 9? That's 36. So I just added 36 to this problem on the right-hand side of the problem. I can't just add 36. So what I'm going to do over here is say minus 36. Since it's still on the same side, I am balancing by like adding the 36 and subtracting. Where on the previous problem, we added to both sides of the equation. This one, we're on the same side of the equation, so we're going to do and undo. So we're adding 36 and we're taking away 36. And hopefully you understand that that still keeps it balanced. Okay, so I'm going to rewrite this. So I've got my 4, so I still have my f of x equals 4, and I'm going to rewrite this as a perfect square. And hopefully by now you understand this, but just in case, I'm going to point this out. This number, that b term that we halved, we cut in half, that is the number that goes here. So you half it, that number goes right here. And in this case, it's positive, so it's a positive. I did the positive 6 divided by 2, that's a 3. So I half it. When I squared it, it was a 9, which by saying x plus 3 squared, that accounts for that 9. We don't actually have to write the 9 in our equation. So the x plus 3 squared. And then at the end, I have all this stuff that's like this weird extra stuff I don't know what to do with. And so I'm like, okay, well, what's negative 7 minus 36? And hopefully you get that that's 43. Now, there's nothing to solve here because it's f of x equals. So I've got my equation in vertex form. But what if I asked you what the vertex was? So if I needed the actual vertex, hopefully you remember way back at one of the very first screens that I showed you is that this number is the h and this number is the k. Be careful with the signs though. I'm hoping you remember that from previous lessons, but the vertex that I'm going to show you right here, the formula is actually x minus h. So if it's plus 3, then that means originally it could have been written as a minus 3. So it's the opposite of the sign of what you see. So my vertex is negative 3, comma, and then my y value, and you actually do take this sign right here, so it's a negative 43. My y value is negative 43. Okay, that is my vertex because this is in vertex form. Now, quick recap. If you need the vertex, you complete the square, you balance the equation just on one side, and then you just pick out the vertex, the h and the k. I'm going to go back a slide. If you were actually solving, then you complete the square, you balance out the sides. Eventually, like in this case, we square rooted both sides, and then we solved. Be careful of the plus and minus. And then way back at the very beginning, you just found the C part. So you half it, you square it, and in this case, we didn't have to balance out the sides because there were no two sides. All right, I hope you can do this on your own. Just remember, you half it, you square it, you balance out the sides. Good luck.